So starting section 5, so it's 1-5 line graphs. Then the next section we're going to look at scatter plots, which are similar, but you kind of have 2 days to really work on making graphs and getting the numbers right on the axes and things like that, although we've already done some spacing and whatnot on bar graphs. But for line graphs in particular, I want to start out by saying kind of what's special about a line graph is often people say they show changes in data. So changes in data. It's supposed to be 2 words there, changes in data over time. In other words, if you were to do a graph of like what's your height versus your age, you should see as you get older, your height gets higher and higher and higher. So it's change in your height over time. Or like grades, you could say, or something like that. But that gradually getting taller as time goes by, they call that a trend. So a trend, T-R-E-N-D, that's going to be a clear direction in a graph. So a clear direction in a graph. If you wanted to add to that trend, I don't think you really have to, but when you see that trend, when you see that, okay, things typically are going up, then it could help you predict future events. You know, well, if it's going up now, it's probably going to go up in the future. I guess maybe I will write it. You can choose what you do, but that may help predict future events. And the reason that we have that word may is my example about the height. For you guys, you're probably pretty steadily growing in height as you get older, right?
Yeah.
Is that graph going to keep that trend?
No.
Because at what age do you stop growing in height?
Like 30,
Yeah. It's probably earlier for girls, so 8th grade, 9th, 10th. I guess for guys, I probably max out like junior year in high school. I got up to my height that I have right now. So it may help, but you may find that things change as time goes on. So in looking at those trends, I want to kind of show like what are 3 different trends going to look like. And we will get more on this soon, but you could have something like this here. If you have a graph that's typically going up, like this, they'll call that positive or negative, you think? Yep, so that there would be like a positive trend. Or if you had a negative trend, then the data should be generally going down. So that'd be like a negative trend. So for a male, you're graphing the number of hairs on their head with their age, starting maybe at my age. It's going to be going down. Guys tend to get bald, that male pattern baldness. It'll be okay. If you have like data, something like this here, so this is more points rather than a line graph, but are those points really going up or down, or
They're just everywhere.
they're really kind of not doing anything? It looks, if anything, kind of like horizontal. But you could say then for those points at least, so this here has no trend. No trend. I probably wouldn't bother making the chart, and I don't think we'll even necessarily look at those numbers there. But if we were to graph this, I want to go over how do you make your axes. So we'll start by making a graph. The x values are going to be time. So we need to go from 1962 to 1994. To make that easier, we'd maybe go from 1960 up to what number?
2000.
I'd do 2000, just because that's going to be easiest to break up. If you had like graph paper, you probably wouldn't have to do it quite as much. Now, right between those two, right in the middle, between 1960 and 2000 is going to be
1985.
Close. Should be 80. Because we're going up 40 years. 60 to 2000 is 40 years. So half of 40 would be 20. Then you could have like 1970 would be there. 1990 would be there. Label them if you can squeeze in the space. Feeling all right? My y values are going to be these guys. So we have 0.8 up to 3.7. So you would probably start at 0, 0.8 is close to 0, and go up to, if you do 3, you don't quite have enough for the 3.7. No, I like the 4. And then right in the middle, you're going to have a 2. And then you could put in like a 1 and a 3 dash. You could write in 1 and 3 if you wanted to. But pick numbers that you can divide. That's one thing that I'm going to be looking for as you make graphs, is are you spacing things out nicely? Kind of like when we did line plots or bar graphs too. All right, so now as we go through and do points, please don't just draw a line. I had some people do that in my Math 8 class on their first quiz. But instead we actually want to put in points. So I have right here my 1962 and 0.8. So 1962 is going to be right about there. And I need to go up to 0.8. So if this was 1, my dot would be something like that. 1966 is going to be a little over halfway between 1960 and 1970, so maybe right about there. And I need to go up 1.6, so a little over halfway between 1 and 2, something like that. 1970 is 1.7, so 1970 I'm a little higher than 1.6, so right about there or so. And maybe I'll go back to green. 1974 is 1.8. So 1975 would be right in the middle, right there. So 1974 is going to be just to the left of it. And I go up to 1.8. It's a little bit higher than my 1.7. We'll do one more dot and then we'll probably just stop. So I had my 1975, that should be right here. So 1980, so 1978, a little over halfway, so right about there. If I go, so now we're back down to the 1.6, the same height as that pink one. So it'd be something like this. You kind of with me on the dots?
Yep.
And then once you're done with the dots, you can go through and connect those dots. I want to make one point about connecting them. If you could try to make sure your dots still show up, so I probably should have made my dots a little bit larger. That's maybe a little bit of overkill. The point I want to make, though, is I didn't put anything right in there. We don't know what happens between 1960 and 1962 because that wasn't part of the data. So don't actually put that in. We don't want... Okay. If you struggle with that, ask when there's time to work on homework. I'd be glad to help you. Last thing I just want to put in, I wouldn't write this down. Done. But if you look at this, so this is a graph of percent versus year. And when we have this part right here, what's happening to the percent for those years? Staying the same. And now here it's going up, so a positive trend. Is it going up a lot?
No.
No, not really.
Not a lot. But it's going up by
Ooh, it's going up 0.5%. Do you agree? It looks like, if you're looking at the heights, this height change here is half of that original amount. So it almost looks like they're adding 50% onto the percent. But instead they're going from 9% to 9.5%. And even by the time they're here, when it looks like it's gone up like almost, actually, like, it looks like it's gone up 3 times as big, you're only going from 9% to 11%. So I just saw this in the book and wanted to kind of reemphasize what I said a couple sections ago about really watch what they do on the axes. That the numbers that they put there, this is kind of like having a broken axis, that they can make the data look differently than what it really is by changing the axes. If instead this graph here went all the way down to like a 0, then you'd notice that, okay, it's going up, but it's not huge, where instead they started at the 8.